All right, what's up, guys? It's Chronos of Tech, and today I'm going to be showing you guys the numbering system. Okay, so this is important if you're getting into IP4 addresses, IP6 addresses, subnetting, subnetting networks, routing. It's also important for changing file permissions inside of Linux and things like that. So it also comes down to your Linux fundamentals, and it's just really good to know. So there's a couple different numbering systems that I want to go over. I want to kind of explain everything so it makes sense, so I could teach you guys some cool stuff. All right, so the numbering system. So the numbering system that we know is called base 10. All right. It's called that because we have 10 numbers to work with. So our numbers that we work with is 0 to 9. Okay. And we usually increment by 10. So 10, 20, 30, 40, etc. Okay. The next numbering system is the binary numbering system. Now the binary is kind of machine language. Okay. And the binary operates with ones and zeros. Okay, just ones and zeros. This is how machines communicate. You know, your desktop or your laptop or your TV set or your AI machine is operating with numbers, right? It doesn't operate with words of the English language like us. It operates its calculations and logic through numbers, which is called the binary, and we're going to go over what that is. Then there's octal, right? Which is octal, you can say, is I guess base 8. You can call it base 8. And the reason why it's base 8 excuse me, guys, is because there's 8 numbers to work with. Okay, so we work from 0 to 7. 0 counts as a number. All right, and then last we have hex. We'll just call it hex. It's hexagonal or something like that, but we'll just call it hex. And this is base 16 because there are 16 numbers to work with. Go from 0 to 9 and A to F. Okay. Now, how does all of this work? Okay, I'm not sure if I can put this all in one video, but basically base 10 is called, it's like the decimal system, right? So it's like our regular numbers that we use, so I'm not going to go over that. But first I can go over binary. So binary operates in ones and zeros. So if we say, okay, we have a binary of let's say 0 1 1 0 0 1 1. Okay, how would we calculate this? How do we know what this is in decimal form, so that way we actually know how to read it? Well, the way binary works is it multiplies by 2. So for every number, you get 2. All right. So, and we read it from right to left. So we'll say 2, or sorry, we'll say 1, 2, 4, 8, 16, 32, and 64. Okay. And so what the ones and zeros mean is, in a binary chart, zeros mean off and ones mean on. So we only count the ones that have ones in them. So in essence, to get our decimal, we would calculate 32 plus 16 plus 2 plus 1, right? and that equals out to let me pull up my calculator. I don't want to get my math wrong. So that's 32 plus 16 plus 2 plus 1. Okay, so we have 51. So in essence, it's 51. All right. And if we want to take it from decimal back to binary, then how many times does 51 fit into 32? So then we'll just go the opposite, right? So we'll say, okay, well, 51 goes into 32. I believe it's 16, but let's just see. No, it's 19. Okay, so we have 19, right? Wait, hold on. We have 19. Does 19 go into 16? Yes. So what's 19 minus 16? Right. That's 3. Whoops. And then does 3 go into 2? Yes. So that's 1. And then finally 1 goes into 1. And then we get 0. Okay. So, and then as you see, so does 51 go into 64? No, so it's off. So it's a 0. Does it go into 32? Yes, so we turn it on. Does it go into 16? Yes, so we turn it on. Does 3 go into 8? No, so we turn it off. Does 3 go into 4? No, so we turn it off. So that's kind of how binary works. All right, I hope you guys get that. Now, if we want to do octal, wait, whoops, let's just put 0, 0. If we want to do octal, then we'll do, so we have 3 here, 3. So let's add 2 more values. So let's say, whoops. So let's say 0. Whoops. And let's say 0. So we have 3, 3, and 3. So we have 9. Okay, 64 is 128. And I believe that's 200 and not too sure. Let's calculate it. 128 times 2, 256. So we have 9 values, and we have 256, 128, 64, 32, 16, 8, 4, 2, 1. Okay. Now octal is a little bit different. In the sense that it calculates 3, so in blocks of 3. So if you imagine like an imaginary line that cuts off into chunks of 3, and that's kind of how it works. And then the values for octal end at 6. So we have 6. We have 4, 2, 1. 4, 2, 1. 4, 2, 1. So for every 3 values, it's either 4, 2, or 1. Okay, so if we said, okay, well, we have a decimal of 55, and we want to know what the octal was for that, then what we would do is we would start off on the right. See if I can get there. So we'll start off on the right. Whoops, I gotta turn off my phone. I have I'm supposed to have this date later. I'm gonna have to cancel though. Alright, so if we want to do well, let's not say decimal, because decimal typically you'd want to put it into binary first and then into octal. But if we had binary values, so let's say our binary value was, let's say 1, let's say 1 0 0 1 1 0, and let's say 1 1 1. Okay, that was our binary value. If we want to go octal for that, then we will start from the right side and we would calculate, okay, 1 1 and 1. So all those binaries are on. So each of those values is 4 plus 2 plus 1, which gives us 7. Okay, so we have 7 for our first octet. Then our next octet, we have the value of 2 and 4 on, so we have 6. Okay, and in our last octet, we only have 2 on, so we have 2. Now the way you read this out is 267. It's not 267. It's 267. That's our octal value. Okay. Now this is similar to file permissions, because in file permissions you do octal. But I'm probably gonna make a later video on that eventually to show you guys how file permissions work in Linux. But that's basically how octal works. And then lastly, we'll get into we'll just call it hex, but it's actually called hexagonal. All right, and it's the same thing. It's the same concept, but instead now we lump it in chunks of 4. Okay, so for hexagonal, it would be, let me go back. It would be these 4 lumped in a row. So, right, and then these 4 lumped in a row, or these 4 lumped in a row, and these 4 lumped in a row. Okay, so you would have 1 2 4 8. Okay, so we have 8 here. We have 4 2 and 1, right? 8 4 2 and 1. Okay, so we have 4 values. Now if we're going to calculate this binary, and let's make this all ones, then we'll say, okay, well, we have 3 1s and 1 0, so we have 4 plus 2 plus 1, which equals 7. And then we have another 4 values, which is 1 plus 2 plus 4 plus 8, which equals 15. Right? 8 plus 4, 12, 14, 15. All right. Now, for 15 on a hexagonal, we don't just put 15, because 15 is 2 numbers. So for our hexagonal, if you remember, we have 0 to 9, and then we have A to F. So we have letters in 0 to 9. Each letter stands for a number. So A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. So because we have 15 as our last value, it would actually be F7. And that would be our hexagonal value. Now where are these used in the real world? Right? Now binary would be used for machine language, machine learning, AI learning. Right? How AI machines calculate numbers, things like that. That's binary. Base 10 is kind of what we use, to calculate our numbers on a regular, human math, you would call it, right? Like it's human math, and then it's machine language. Octal, which is base 8, would be used in, actually, maybe we should write this down, right? So base 10 is basic, base 10 is basic math. Binary is machine language, how machines communicate with each other. Octal would be used in IP6 addresses. It would also be used to change file permissions in Linux. And it would also be used in subnetting. So when you get into networking and you start or if you're interested in networking, you're interested in subnetting and file permissions and IP6 addresses, or even IP4 addresses, IP version 4 as well, then you're going to be looking at the octal number set. And then for hexagonal, it's mainly used in MAC addresses. Okay. That's why you see F, A, B in most MAC addresses, because they're operating from a hexagonal format. So that's basically the number system. I hope I explained that well. You know what I mean? I hope you guys understand it. And yeah, that's basic numbering system. And as a review, base 10 is basic math. Binary is machine language. Octal is a base 10, so total number of 8, and it has many uses, major in networking and also in changing file permissions, which is kind of important if you don't want people having access to your files or other users having access to your files. And then hexagonal is basic MAC addresses, so able to output MAC addresses or convert it into binary or even base 10 languages. All right. So I hope you guys enjoyed the video, man, and I'm out.